Let's take a breather from the theory and return to seeing more of the SCs and SCCs dichotomy in practice. In this section, we'll attempt to deploy application code within a containerized environment or a pod on the OpenShift cluster. The application that Brady's team has been handed by the CIO office, Amy, requires both a specific user ID and a shared group ID in order to access the relevant data within Stack Corporation's IT estate. This will require us to take steps in order to request special permissions beyond the default access or the restricted levels of access for the pod and the containerized code that it's supporting. The pod's SCs, as defined in the YAML-based deployment manifest that we'll craft, need to specify the exact user ID and group IDs needed by the company's data. Of course, this manifest only constitutes a request made by the cluster. It's not a mandate or a command, and for that reason, we'll need to validate that pod's SC in accordance with what is permitted via the cluster's SCCs that were defined by Brady and the CSO office. Whether or not Amy's application code is successfully deployed is contingent on the pod SC's validation against the cluster SCCs. If there is not an SCC that can validate the requested SC, then the pod will not deploy to the cluster. In order for Brady's team to deploy Amy's containerized application code, the pod making the deployment must define a custom SC that requests the following levels of access control. The application must run as user ID 1234, application must run as group ID 5678, supplemental group IDs 5777 and 5888 must be added, and the application must use a file system group ID of 5555. The sample deployment manifest YAML file has been provided and prepared for you based on those requirements just described. Download the YAML file from the GitHub repository that's linked in your documentation and save it to your local desktop using the file name of deploy_sc.yaml or an alternative one of your choosing. As previously mentioned with the YAML files, take special care to preserve the white spacing and empty new lines when saving your file, as precise formatting is important to how YAML files are interpreted by the cluster. Take note of lines 19 and 20, which align with the first two requirements specified earlier. A file system group ID of 5555 has similarly been added on line 26, and the supplemental group IDs being requested are detailed on line 27 of the YAML file. In order to submit the request and generate the pod deployment, return to your terminal window, still connected remotely to the OpenShift cluster via the OCCLI, and submit the following instruction. Now let's check whether the deployment succeeded or failed based on the parameters requested in the YAML deployment manifest. Open your web browser once again and return to the OpenShift cluster web dashboard, then switch to the developer perspective and open the topology tab from the left-hand menu. You should see two deployments at this point in time, the deployment that was made earlier, SCC tutorial deploy default, and the deployment submitted just moments ago, SCC tutorial deploy SC. What is the status of the pod that we just attempted to deploy? Click on the application tile and drill down into the Resources tab to retrieve more details on the deployment status. Let's examine what went wrong. First, we need to inspect the deployment for errors and correlate those with the specific permissions that were outlined in the cluster SCCs. We will do so by checking the status of the replica set. All pods are owned by their respective deployment, and the deployment manages pods or pod sets with a resource called replica set. To know which replica set to inspect more deeply, use the terminal to describe the deployment just attempted by referencing the deployment's name. The output generated will describe a replica failure, as shown on the screenshot in your documentation. The presence of a replica failure with reasons given as failed create tells us that the deployment failed, presumably because of a mismatch between the permissions the pod's SC requested on behalf of Amy's application and the SCCs for the cluster as defined by Brady's security team. More specific details on why the replica set failed can be obtained using the following command. Copy and paste the output from terminal into a text editor, as that will make it easier to parse and read at a glance. Note from the highlighted portion of the output that the error stems from being unable to validate against any security context constraint due to the FS group and run as author values that were requested within the deployment manifest. This result is not entirely unexpected when you consider that the default service account does not have the permissions necessary according to the cluster SCC to request these protected Linux functions. And that includes things like the provider any UID, forbidden, not usable, by user, or service account message that you might have received through the console. There are also two remedies to this conundrum. Amy's team could reauthor the deployment manifest and re-architect the application that's to be containerized to request less privileged access and remain compliant within the existing constraints of the cluster's SCCs. Or alternatively, Brady's team could define a new SCC that accommodates the level of permissions being requested by Amy's application and the deployment pod. As things stand, the deployment will never succeed, and hence the fail-fast response of creating a tombstone for the failed deployment so that Brady or Amy can decide whether to inspect what failed, change their SCCs or their SCs accordingly. And all this, of course, is by design. We want things to fail and not just march ahead steadily without the approvals needed. It is overall far better to have an unauthorized deployment fail completely with an explanation given as to why than to have a deployment brought into a live state or production state without the permissions necessary to access data from the cluster. The team managing the applications or security environment can readily determine that the deployment failed because of insufficient access or access to functions that are not permitted, rather than waste cycles debugging why a deployed application isn't behaving as intended. So, for example, why an application can't pull data out of the company's database.